Hello, Algebra 1 class. Today we're going to be looking at applications of multiplying polynomials, specifically areas of rectangles. So our first problem that we're going to look at is that you are designing a rectangular skateboard park on a lot that is on the corner of a city block. The park will have a walkway along the two sides. So here's our walkway along the two sides that are along the street. So here's our walkway. The dimensions of the lot and the walkway are shown in our diagram. We want to write a polynomial that represents the area of the skateboard park. Here's the park. So in order to write a polynomial that represents the area, I have to know what the base of the park is and what the height of the park is. So to find the base of our park, we know that the entire distance across here is 45 feet. If we take away the x that represents the walkway, we're left with 45 minus x. On the height of the rectangle, our entire distance is 35 feet. If we take away the x that represents the walkway, we're left with 35 minus x feet. So our area then is equal to base times height. So we are going to take the base, 45 minus x, multiplied by the height, 35 minus x. And we're going to multiply these two binomials together. Remember, we're going to use multiplication, which is defined by the acronym FOIL, first, outer, inner, and last. So starting with our first terms, our 45 times our 35, that's 1575. Our outer, 45 times negative x is negative 45x. Our inner, negative x times 35 is negative 35x. And our last, negative x multiplied to negative x is positive x squared. Taking our polynomial and writing it in standard form, we're going to start with the highest power of x, which is the term x squared. Then we have two terms that have the variable x. We have negative 45x and negative 35x, which add to negative 80x. Finally, we have our constant 1575. So our expression, our polynomial that represents the area of the skateboard park is x squared minus 80x plus 1575. Now that we have the polynomial that represents the area, we want to know what is the area of the park if the walkway is 3 feet wide. Well, the walkway is this dimension that is defined by x. So we want x to be equal to 3. So we're using our polynomial and substitute 3 in for x. We have 3 squared minus 80 times 3 plus 1575. So we have 9 minus 240 plus 1575. So we add these together. We get 1584 minus 240, and that comes out to be 1344 square feet. Move that up so you can actually see that. We had 1584 minus 240 is 1344 square feet. Okay, now let's look at our next example. Our next example is another rectangle. On this one, we are planning to build a walkway that surrounds a rectangular garden. So here's our garden on the inside. And going all the way around the garden, we have the walkway. We want to write a polynomial that represents the combined area of the garden and the walkway. So the combined area would be the total area enclosed in this large rectangle. So we need to find the base and the height of this large rectangle. We need the total distance from one corner to the other. So as we go across here, we see that our first part here is the width of the walkway, which is x feet wide. And then we continue to move across, and we see that that distance is across the same as across the garden, which is 10 feet. Finally, as we continue to the corner, we have another width of the walkway, which is another x. So our total is 2x's plus 10, or 2x plus 10 feet for our base. For our height, we're going to do the same thing. As we start along the height of this large rectangle, we start with a distance that is equal to the width of the walkway, which is x. Then we proceed across, which is the distance of the width of the garden, or the height of the garden, which is 9 feet. And finally, another distance of the walkway, x. So our total would be 2x's plus 9, or 2x plus 9 feet for our height. So area equal to base times height. Our area is equal to our base, 2x plus 10, multiplied by our height, 2x plus 9. I'm going to use FOIL to multiply these out. So starting with our first term, 2x times 2x is 4x squared. Outer, 2x times 9 is 18x. Inner, 10 times 2x is 20x. And finally last, 10 times 9 is 90. Combining our like terms, starting with our highest power of x, so our first term is the 4x squared. And I have two terms with x, 18x plus 20x is 38x, and then our constant term of 90. Now we want to use that and find the combined area when the width of the walkway is 4 feet. Well, our width is x, so I want to use x equals 4 in my area equation. So I have area equals 4 times 4 squared plus 38 times 4 plus 90. Order of operations, we do our exponent first and then the multiplication. So 4 squared is 16 times 4 is 64. And then I have 38 times 4, which comes out to be 152. And then we add 90. So our total area, when I add these together, is 216, plus 90, which is 306 square feet. Okay, our next question on this is, what is the area of just the walkway? Well, the walkway is just this border around the garden. So if I take the total area and subtract the area of the garden, I'm going to be left with the area of the walkway. I know my total area is 306 square feet. My garden area is just this inside area with a base of 10 and a height of 9. So base times height, 10 times 9 is 90, and that's going to give us the area of our walkway. So 306 minus 90 is 216 square feet for the area of just the walkway. We're going to finish with simplifying a polynomial expression. In this polynomial, we see that we need to apply the distributive property. We have 3x multiplied by the binomial 2x plus 5. So let's start with that. We're going to distribute, taking 3x times each term in the binomial. So we have 3x times 2x is 6x squared. 3x times 5 is 15x. And then we have the negative 4x that is distributed into this trinomial. So negative 4x times each term in the trinomial, starting with negative 4x times x squared, is negative 4x cubed. Then negative 4x times negative 3x, which is 12x squared. And finally, negative 4x times 6, which is negative 24x. As we finish, we're going to combine our like terms, and we're going to start again with the highest power of the exponent. So we're going to start with negative 4x cubed. So we have negative 4x cubed. And then we have two terms involving x squared. We have 6x squared plus 12x squared is 18x squared. Then we have 15x minus 24x is negative 9x. And we've completed our applications for multiplying polynomials looking at area problems. You're now ready for your homework.